circuits, what we have done? In electric circuits, we have done LR circuit. We wrote the equation of LR circuit. What's the equation of LR circuit? What's the equation of LR circuit? Inductance and resistance in series. Yes? Can anybody tell me?
L di by dt plus Ri equals to 0. Equals to E.
Equals to E. That's right. That's right. So we did it yesterday. We saw a general example also of that. One particular example also we saw. Today we are going to see RC circuit, that is resistance and capacitance in series, and we will see the general solution as well as we will see the examples. So in the general solution, the method which is there will be used in the examples also. So let me start directly with an example. Take down the question. The equation of an electromotive force. The equation of an electromotive force in terms of current I, the equation of an electromotive force in terms of current I for an electric circuit
Ma'am,
in terms of current I. Actually, this is a bit the one which will be taken later. If please take the cut this, we will take it later on. Take the one which I am giving now. The charge Q on a plate. Please consider this example, okay? Because we'll start one by one. From a simple one, we'll go to the difficult one. So take down this question. The charge Q on a plate. The charge Q on a plate of a condenser. Charge Q on a plate. Charge Q on a plate of a condenser of capacity C, of a condenser of a capacity C, charged through a resistance R, charged through a resistance R, charged through a resistance R by a steady voltage V, by a steady voltage V, by a steady voltage V, satisfies the differential equation, satisfies the differential equation. We will write down the differential equation, okay? You don't keep some space, full stop. If Q is equal to 0, if Q is equal to 0, at T is equal to 0, if Q is equal to 0, at T is equal to 0, if Q is equal to 0, at T is equal to 0, then find the charge Q as a function of T, find the charge Q as a function of T and current flowing through the plate, and current flowing through the plate, current flowing through the plate. Is it okay? So first of all, for what we have to do is, we have to see which type of circuit it is. It is said a capacitance is there, condenser has a capacitance C, and resistance R is in series with a voltage V. Okay, so it says RC circuit. It's a RC circuit. Correct? Everyone, is that correct? Understood?
Yes, ma'am.
Yes,
Yeah.
ma'am.
So yesterday we saw what is the voltage across resistance by Ohm's law. It is Ri. And what is the voltage across capacitance? It is Q by C. Okay. And what is Kirchhoff's law? Kirchhoff's law says that voltages across all the elements which are there in the circuit is equal to the total voltage P. So Ri plus Q by C is equal to P is the equation. Is this clear to everyone? Voltage across resistance is Ri. Yes. Okay. Now it's does it look like an differential equation? Is it a differential equation? Right now it is not. So we will convert it to differential equation. Yes. How we can do that? We know that I is equal to what is
dq
I?
by dt.
dq by dt.
Very good. It is dq by dt. So r dq by dt plus q by c is equal to this is your equation. What type of differential equation is this?
Linear.
Linear. This r is there that I have to remove to make it the coefficient of the differential to be 1. So I have to divide by r. So q by rc is equal to p by r. This is your differential equation of the given RC circuit. Is it okay? Which is the most general differential equation of the RC circuit. Now we will solve this. So once it is linear, your integrating factor is nothing but e raised to integration p d.
I
Yeah. So what is p? 1 upon RC. Q
1
is your
upon rc.
linear variable. So 1 upon RC is your p. So it is e raised to integration dt by RC. R is your constant. So it is e raised to t by RC. So this question are there in your lecture. What is the integrating factor for the differential equation of an RC circuit? So what it is? What is that?
e raised to the power p by rc.
Absolutely right. Very good. So e raised to t by RC is the integrating factor. And then what's the solution? The solution is your linear variable t, that is dependent variable q, sorry, dependent variable q into integrating factor is equal to integration of the right hand side. What is the right hand side q? It is v by r. So v by r e raised to t by rc dt plus constant of integration k. And therefore your answer will become q is into v raised to t by rc is equal to v by r. What is the integration of e raised to t by rc? E raised to t by rc. Yeah, divided
1
by
by rc.
1 by
By
rc. Very
RC.
good. Yeah. So r and r gets cancelled, and your equation becomes q is equal to, just see, I am trying to remove e raised to t by rc. So I multiply throughout by e raised to minus t by rc. So q will become bc plus k e raised to minus t by rc. Is it okay? Q is equal to bc plus k e raised to minus t by rc. Clear everyone?
yes.
Yeah.
Yes.
Now, therefore, what will be your further answer? We have to find the value of this unknown k, constant of integration k, for which initial condition should be used. What is the initial condition given to you?
q0
T
t0.
equals to 0, Q is
And t is equal to 0, q is equal to 0. Okay, and therefore 0 is equal to bc plus k into e raised to 0. So k is equal to minus bc. And therefore your answer is q is equal to bc minus bc e raised to minus p by rc. Take bc common, it is 1 minus p to the power minus p by rc. So this is the charge at any time t in the circuit. Charge at any time t in the circuit. V into C in bracket 1 minus e raised to minus p by rc. The way we got it for current in an LR circuit, it was E by R into 1 minus e raised to minus RT by L. So here we are getting the charge in the circuit at any time t. Clear? Everyone, is this clear?
Yes, ma'am.
Yes,
Yeah.
ma'am.
So what's this is the first part. Now what is the second part which is asked? Find the current flowing through the circuit is also asked now at any time t.
Yes, ma'am.
Okay, so what is current? dq by dt. I is equal to dq by dt. So I of t will be derivative of this equation can call it as 1. Derivative of equation 1 with respect to t. Bc is constant, it will remain as it is. Derivative of 1 is 0. Derivative of this is minus, into minus it will become plus. E raised to minus t by rc into 1 by rc. Derivative of 1 upon t upon rc is 1 by rc. So c and c gets cancelled. We get v by r into e raised to minus t by r. This is the current flowing through the circuit. Is this clear? At any time? Any doubt to anyone in this?
No.
Okay, so this question, integrating factor is there in your MCQ. This equation, finding the current given the charge is also there in your MCQ. Given the equation of what is RC circuit with the integrating factor, what is the charge flowing? That is another MCQ question. So these all are there asked for 2 months till now. They will be same month class for question. Okay, or maybe they will be asked this time for 2 months. Clear? Everyone?
Yes, ma'am.
Yes, ma'am.
What is the basic thing that you are understanding? If you are given an RC circuit, then you can find the current flowing through the RC circuit at any time t. You can also find the charge which is flowing through the circuit, which is there in the on the capacitor or on the condenser at any time t. That also can be found with the help of this differential equation. Okay. So now I'll give you a question which will be on numbers, which is there. Take down and try to solve it on your own. All steps are same. Only now you are given the values of number, that is B, C, R, everything will be given. So take down that question and tell me the correct answers. Okay. A capacitor of 0.01 farad. A capacitor of C is equal to 0.01 farad. 0.01 farad. In series with a resistor R, is equal to 20 ohms. R is equal to 20 ohms. If
Please repeat.
a capacitor C is equal to 0.01 farad. Capacitor C is equal to 0.01 farad. In series with a resistor R, equal to 20 ohms, is charged from a battery E, equal to 10 volts, assuming that initially the capacitor is completely uncharged, determine the charge Q of t, voltage V of t, on the capacitor, and current I of t in the circuit. What is the only part which is different from the previous question? There also voltage is added. Voltage on the capacitor is given by
V is equals to IR.
capacitor.
Q equals to CV.
Q is to CV.
Q equal to CV.
That is Q by C is equal to V.
Yes.
So you get it from here. Q divided by C will be your equation. Is it okay?
Yes, ma'am.
Yeah. So try to solve it, put the numbers and you will get the answers. So tell me the answer is Q is equal to some number into 1 minus e raised to minus t, some number. So that will be your answer. Only here you are given the values. So try to do it quickly and tell me. So almost everything will be same. How will you write the solution of this differential equation? R dq by dt plus q by c is equal to b. This is your equation. Then solving it, you will get same thing will happen, because what is the initial condition given? The capacitor is completely discharged themselves. That means no charge initially. So same initial condition. At t is equal to 0, q is equal to 0. So this only will be your answer. Q of t is equal to Vc. Q of t is equal to Vc into 1 minus e to the power minus t by Rc. Just to put the value of B and C. What is the battery source? E it is said here. It is written B. There it is. E. What is given? How much is that? How many volts? E
10 volts.
10 volts. And what is the capacitor?
0.01 farad.
0.01 percent. 1 minus E to the 1 minus C upon RC. What is R is 20 actually.
Yes.
So 20 into 0.01. So what does that turn out to be? 0.1 into 1 minus e to the power minus 20 into 0.01 is 0.2 and 0.2. 1 by 0.2 means 5. So minus 5. Check this. So this is the charge at any time t. 20 into 0.01 is 0.2 in the denominator. 0.2 in the denominator means 1. Denominator 1 by 5. So that 5 will go down and it is 0.1 into 1 minus e raised to minus 5. That is the amount of charge which is flowing through the circuit at any time t. Okay. Is it okay? Yes, yes, very good, Ankita. That's right. Then what is second one is voltage. Voltage across capacitance in that is Q by C. So that turns out to be Q by C from where? From 1. From 1. It is nothing but Q by C is E into, rather than E into, you may get confused with this V and voltage, so we can write it as E also. Okay? So that is given to be 10 times 1 minus e to the 1 minus 5.
E raised to minus 5t.
That's the
Yeah.
answer. Voltage on the capacitor is 10 into 1 minus e raised to minus 5. And the third thing is current. So I is equal to dq by dc. Again from equation this we can follow this one. So if you differentiate this with respect to t, 0.5 will remain as it is, get rid of 1 is 0, minus and this minus will come. So this 5 e raised to minus 5t. Your answer is 0.5.
minus 5t.
Right. Current flowing through the circuit is 0.5 e raised to minus 5. Okay? Clear?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes. So that is the examples which can be asked on RC circuit with simple battery source of some voltage, 10 volts, fixed volts. Okay. Now sometimes it is given to be a a function dependent. The battery source which is there, it will be sinusoidal wave or something like that. So we'll take that type of example. Okay. Shortly. So finish writing all this.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, so now take the question which I had started with, the first question which I had give you all. Yeah, the equation of electromotive force, in terms of current I, for an electric circuit, having resistance R, and a condenser of capacity C, in series, is given by E is equal to, yes, who will tell me current you want, they don't want in terms of Q, is given by E is equal to Ri plus integration of I dt by C. Let me check it. That's it. Integration of I dt plus C. This is in the question only they are given. Find I at any time t. If E is equal to E0 sin omega. If E is equal to E0 sin omega t. That means it is time dependent. Okay, the source which is given is time dependent. It's a sinusoidal wave. and then we will find out what will be the current flowing through the circuit at any time t. So first of all, you have to get into picture the differential equation. I can see integration into this. I do remember I told you a differential equation will never have integration. So I have to get rid of this integration. So what will you do?
And we can write dq by dt I is equals to.
We will derivate it.
Differentiate.
Yes, there are two ways of doing it. The ways, I think so Saurabh said that if you try to substitute I is equal to dq by dt and then remove dt, again you have to put I is equal to dq by dt, solve it, and then get again what is I, which is again dq by dt, answer whatever you get the way we did in the previous question. But here it is given in this form and current can be found directly because I have I. So if I differentiate this equation, then what will happen? This integration will go, dt also will go. Obviously, I differentiate with respect to t, so that integration and dt will go, and I get an equation which will be derivative differential equation as well as it will be in terms of I. Rather than going first to q, then to find dq by dt, we can directly rewrite this equation as a differential equation in variable I as your dependent variable. Clear?
Yes, ma'am.
Yeah.
Yes,
So how
ma'am.
we
Yes.
how we are going to do that? Just let me rewrite it. Ri plus integration I dt. See the fixed value. That's why I'm writing it outside the integration. Is equal to E0 sine omega t. Now many students where they go wrong. Generally, you have the habit of writing E and then you don't do the differentiation of that term, which is on the right hand side, and then everything will be different. The answers will be different. Okay, you won't get the correct amount of current which is flowing through the circuit with the help of this sine or cos. Okay, so now I will differentiate this. Differentiate with respect to t. Okay, so d by dt of Ri plus d by dt of integration I dt by c is equal to d by dt of E0 sine omega t. If you forget this, then your value of the current which you are going to get in terms of t will be wrong. So this is R di by dt because R is a constant plus this dt and dt gets cancelled. This d and integration gets cancelled. So it is I by c is equal to what's the derivative of this? E0 is the fixed value. Derivative of psi is cos of omega t into omega. Is this clear to everyone?
Yes, ma'am.
Yes, ma'am.
So now we will rewrite it in the proper format to make it linear differential equation and then we solve it. So that will be the answer. So
मॅम
di by dt.
मॅम ते कॉस ओमेगा टीच्या खाली ओमेगा नाही येणार का?
It is differentiation.
Integration
Na?
में होगा ना.
Integration we have in the denominator. This is derivative. So I have multiplied omega. This is again one more thing which generally you get mixed with. Whenever it is differentiation, the derivative is multiplied omega. Whenever it is integration, you divide it by the term, by the function. Clear with that?
हा येस मॅम येस.
So I is equal to omega t0 upon r cos omega. This is your linear differential equation in I. Linear differential equation in I, and therefore the integrating factor will be fixed. That's it. E raised to integration of 1 by RC dt, and that is E raised to t by r. E raised to t by r. And therefore solution is the solution is I is a dependent variable. E raised to t by rc is equal to integration of omega t0 by r e raised to t by rc cos of omega t dt plus constant of integration k. Okay. Now I have given you the formula set the for integration formula of e raised to at cos of dt. And I told you in electric circuits, we are going to use this specific formula because I try to write down the phase change only in terms of cos. So it is e raised to at upon square root of a square plus b square into cos of dt minus phi, where phi is equal to tan inverse of b by d. I have given this formula. in the beginning, the very first lecture. So we are going to use this formula only because whatever happens, we are going to get the answer of cos in terms of cos. If it is sine, there will be a change here in sine. There are other two formulas also of cos and sine respectively. A cos bt, B sin bt, or A sin bt minus B cos bt. That we are not going to use because if I want to change or find the maximum current flowing, sine becomes maximum, that time cos becomes minimum. Are you getting it? And that's why it becomes difficult to take the modulus and solve it, right? So if you use this formula, the maximum value of cos will become 1 and it is alone. There is no sine term. That's why this formula will be used for electric circuit wherever you get the terms of the type e raised to 80 cos of 80. Okay? Samajh
Ma'am.
Yeah.
Yes,
So use this formula and tell me the answer. Final answer. It is e raised to. Can you see this side? This part here.
Yes,
It
ma'am.
is I e raised to t by RC is equal to omega E0 by R. This is fixed. Okay. Now integration of the term which is there will turn out to be e raised to t by RC and CI to the. I'll write it down. Huh? This is product and it is written here. E raised to t by RC upon square root of 1 by R square C square plus what is the value of B? Value of B is omega square into cos of omega t
omega t
minus
minus phi.
phi. When phi is equal to tan inverse of B by
Omega
A
upon
omega upon 1 by R.
1 by RC. Yes.
So that will become omega R. Okay. So we write it plus constant of integration has to be written plus k. You can't see that. I'm saying it, so please write it down. Plus constant of integration is there. So I will rewrite it in there, the space. So your solution of the current going through the circuit is given by. Should I remove that e raised to t by RC by multiplying by e raised to minus t by RC?
Yes, ma'am.
So I of t becomes equal to omega E0 by R into e raised to t by RC will go, which is cos of omega t minus phi divided by this c, it is square root of 1 plus R square C square omega square, and RC will be the denominator which will come in the numerator here. Without square root, it will come as RC, not R square C square. Okay? Plus K into e raised to minus t by R. So R and R gets cancelled, and therefore current flowing through the circuit at any time t is given by omega E0 C cos of omega t minus phi divided by root of 1 plus R square C square omega square plus K e raised to minus t upon R. Okay? Is this fine? Clear to everyone?
Yes, ma'am.
Yes, ma'am.
We can find the value of t if the initial conditions were given. So, is there anything said about the initial condition? Initially, no charge or something, nothing is given, na? Nothing is mentioned. So, let it be this one. So, this is the final answer. Otherwise, when t is equal to 0, current if it is 0, then we get the value of k. If it is mentioned, then we find the value of k. If it is not mentioned, then let it be this one. Clear?
Yes, ma'am.
And again, in the
Yes.
MCQ, they will be asking you the same type of questions. What is the integrating factor? Given the integrating factor, what is the value of the current? They can ask you what is phi, that is tan inverse of B by A, but in this particular example, it will be tan inverse of omega into RC. 1 upon RC in the denominator will go up in the numerator as RC. So tan inverse of omega RC, that they can ask. They can ask for the final answer also. Okay? So, yeah. Any doubt to anyone? So let me give you one more question, which is a bit different from this LR circuit. And you have to find what is the maximum of the current which is flowing, and then how much time it will require to find the 90% of the current to be flowing, or 50% and so on. So that will be a question from LR circuit. So have you completed writing this? There are many questions of this time in the book also. Okay. Maybe Ramanat is there, or even in the local publication. Should I give you the next question then?
Yes, ma'am.
Okay. Please take it down and try to solve. Okay. This is a bit different. If you understand this question, then actually there is no need to solve many examples also. Once you understand the concept, it is very, very simple. Only you should know what is the voltages across each of this element which are in there in the circuit, and the total EMF, induced EMF which is there, or the battery source which is there. End of the question. In a circuit containing inductance L, and resistance R, inductance L and resistance R, with voltage E, the current I, here they have given I as capital, okay? All the alphabets are capital. The current R,
Can you repeat it?
yeah. In a circuit containing inductance L, resistance R, voltage E, the current I in the circuit is given by N di by dt plus Ri is equal to V. Voltage E segment E. The current I in the circuit is given by N di by dt plus Ri is equal to E. Okay. Given L is equal to 640 Henry, R is equal to 250 ohms, and E is equal to 500 volts. E is equal to 500 volts. I being 0 at T is equal to 0. I being 0 at T is equal to 0. Find the time required for the current to reach find the time required for the current to reach 90% of its maximum value. 90% of its maximum value. 90% of its maximum value. So you can start with the
Ma'am, can you repeat the last sentence?
find the time required for the current to reach 90% of its maximum value. 90% of its maximum value. Clear? 90% of its maximum value. So let us go to the question now. You write it in the general form because all the numbers, all the things which are there, this resistance and T, all of them are fixed constant. That's why directly you get that T is to RT by N, that method only, and then we'll see at the end what is the basic difference. So those who have understood the question can start, and those who have not, will please listen. So your differential equation can be rewritten as di by dt plus R by Ni is equal to E by and therefore your integrating factor is e raised to integration r by l dt, that is e raised to r by l. This is the integrating factor. Correct? Now let us go to the solution. So what's the solution? You are going to find the current flowing to the circuit. So what is the current flowing to the circuit? It is I of t is equal to into e raised to rt by l. This is a solution of linear differential equation. I of t is equal to I of t into e raised to rt by l is equal to integration of q. What is q? E by l. So e by l e raised to rt by l dt plus the constant of integration k. So I of t e raised to rt by l is equal to e by l e raised to rt by l divided by r plus k. Integration, then the derivative is divided. So l and l gets cancelled, and that's why I'll write it directly now. It is equal to e by r plus k e raised to minus rt by l. You can find the value of k with the help of initial condition. At t is equal to 0, given in I is 0. Therefore, k is equal to minus e by r. And therefore, the current flowing through the circuit is e by r is common, 1 minus e to the power minus r by l. This is your value. Substitute the value of E, R, and L. That's the answer of this specific question. So what is that? I of t. This I'll count as 1. This equation I'll count as 1. This one. This is 1. So I of t is equal to what is E? 500 volts. And what is R? 250. 1 minus e to the power minus rt by l. So r is 250, t by 640. So rewriting it, this I of t is equal to 2 times 1 minus e to the power 250 upon 640. Just calculate what it is.
0.39.
0.39. That is your answer in terms of numbers. Okay, what is asked in the question? Is this what is asked? Is current flowing through the circuit asked?
No, ma'am.
No. What is asked?
Ma'am, time required
Time
of the
required.
90% of maximum current.
Yes. So what you have to do first of all, you have to find the maximum current. We have done this in yesterday's class. What is the maximum current which is flowing through the circuit? If you know that it is. Yes. Everyone knows that Imax is E by R. You did it yesterday. When t goes to infinity, e raised to minus infinity will become 0, and the maximum value will be E by R. Okay? So what is asked is, find the time required for the current to become 90% of the maximum value. Is this clear what I am writing? 90% of E by R. Yes or no? Very simple.
1.8
Find an
and
answer. Yeah. So let me just put yes.
मैम 5.89 सेकंड जा रहा है.
Ma'am, 5.9, ma'am. 5.9 second.
Yes. Because everything units are
5.89.
Yeah. Something like 64 by 25 ln of 10. Yeah.
Yes, ma'am.
Yeah. They don't expect you to tell the exact answer in decimals. They give you the option this value only 64 by 25 into ln of 10. So that much also if you write in seconds is the answer. Okay. So how do we get it for those who are not able to understand it? Yes. So what is the time required for 90% of the maximum? Maximum if it is E by R, 90% क्या होगा? 90 by 100 of E by R. That's why your value will become now I of t, where it is capital I. So I of t will become from where I am getting from 1. From 1. 9 by 10 of E by R is equal to E by R into 1 minus e to the power minus RT by L. So E by R cancels. 9 by 10 minus 1 is equal to E raised to minus RT by L. and this becomes minus 1 by 10 e raised to minus RT by n. So minus, how do you get rid of this minus sign?
Ma'am, we can get ln.
Yeah, so you have to take ln of minus 1 by 10. I have skipped something. That's what negative branch of this negative sign. Yeah,
Yes, ma'am, that negative.
this minus sign, this minus sign. Minus e raised to minus RT by L, because negative branch of logarithm is not defined directly. Okay, so 1 by 10 is equal to e raised to minus RT by L. So ln of 1 by 10 is equal to minus RT by L, and therefore minus ln of 10. Why this everyone knows? Why has written this minus ln of 10? Log of a by b is log a minus log b, but log 1 is 0. So it is minus log 10 is equal to minus RT. This gets cancelled, and therefore the time required is L by R ln of 10. L by R ln of 10. L is 640, R is 250, ln of 10 seconds, and that is 64 by 25 ln of 10 seconds. Is this clear, everyone? This question is there for 2 marks. What is the time required for the current to reach 90% of its maximum if the differential equation is given? Solution is not given, so you should know the solution and then you should put this value. But this is generally fixed. L by R is fixed. ln of 10, what is the number that you will get? 90% होगा तो 1 by 10. 50% होगा तो what you will get? If the question is find the time required for the current to reach 50% of its maximum, what will be your answer? Half time. So take 50% under 50 by 100 in minus 1, so that is 1 by 2 minus 1, so that is half. So here it will be ln of 2. Is that clear? Everything else will be same. So with L by R, this number only changes. Or shortcut to find to solving the MCQs. Is it okay? Everyone?
Yes, ma'am.
Yeah.
Yes, ma'am.
Fine.
Yes, ma'am.
Yeah. So these are some questions on LR circuit, RC circuit. I'll ask you one MCQ which is not been covered by the theory questions that we have done. So let me ask you this question. Let's see whether you are able to do. The last part which is there is LC circuit without without EMF that we will do quickly. But before that, let me ask you this question. All that we have studied now, tell me. Yesterday I had asked you that question also. Tell me whether you are able to understand and solve this question. Okay? If Q is equal to E raised to, check that question. If Q is equal to E raised to minus 3t, E raised to minus 3t, minus E raised to minus 6t. Q is equal to E raised to minus 3t, minus E raised to minus 6t. Find the time required. Find the time required for maximum charge to be present. Let me just check exact word. Okay. Find the in an RC circuit, Q is the charge of it's a function of T. Then the time required for maximum charge on the capacitor is the time required for maximum charge on the capacitor is. So this is an MCQ question. Tell me how you are going to do this. And see to it that this time you will definitely have 5 marks. Out of those 25 marks which we give in term work, I will give 5 marks specifically for answering the questions in your regular sessions. When I'm taking your lectures, Last time, the 10 marks were directly given to me from your submission of the assignments. But this time, definitely, only those students who are answering in the lectures, regular lectures, when I'm asking the question, they will be given those 5 marks. Okay? So Q is equal to e raised to minus 3t minus e raised to minus 16. And what is asked is find the time required for the maximum charge to be present on the capacitor. Can anybody tell me how you are going to go about it? When is the charge maximum? Storage is maximum if
It's 1
equal to
T1.
both it is equal at that time.
what is
Potential
it?
drop across both the capacitor and
Voltage drop. Yeah.
that battery is same.
Right now, which relation we have? That is, you are talking about actual experiment which is going on. We are getting we want the relation between, we are given the relation between Q and T. Okay, so using this equation, we have to find when the charge will be maximum. Stored, what is said, on the capacitor. That means what should happen? If there is no flow of current, then the charge will
And
remain.
initially charge will be maximum, ma'am. At t is equals to 0 only.
So you're saying that T is equal to 0 is the answer. Always.
No, ma'am.
No, that is not the case. Yes. So think about it. Good thinking. If the question is given in terms of time and in terms of Q, there will be some relation.
When
Of,
current is maximum,
I0.
when current is max,
when current is max, how can charge be max? The current
Ma'am,
is what rate at which charge changes.
When
Isn't
Q
it?
is
when current
exactly
is
CV.
minimum, when current is 0.
When
When I0.
absolutely right.
I0.
Why did you come to that conclusion when the current is 0? Why did you come to that conclusion?
Ma'am, first current will be increased till to maximum, then it will be decreased and the capacitor will be increased, ma'am.
Correct, absolutely right. The charge will keep on increasing as the current is becoming. Because what is the thing that when the flow will stop, that time the saturation will be maximum. Na? For the student, ENT students are at least trying to understand, getting it. But the computer students aren't thinking even. Yes or no? Anjali, Vedant,
Yes, ma'am.
Yes, ma'am.
yeah. So when will
Yes,
be the
ma'am.
when will be the charge maximum? When the flow will stop, that is current will become 0. Initially, what is happening? Charge is flowing in. That's why the current is going to maximum, and then again it will come down. So when will be the maximum charge again recovered on the capacitor after the current becomes 0? So dq by dt I should become 0. That means dq by dt should go to 0. Are you getting it? And that we can definitely find with the help of this equation. Otherwise, no use of this equation. Na? Always it will be whatever is the relation that is independent. Like that will be the case. Na? That's why Q is given in terms of T, and when you change that Q with respect to T, if that goes to 0, the charge will be maximum. Is it okay? So find what is dq by dt and compare it with 0. So dq by dt with the help of this is e raised to minus t into minus 3 minus or minus plus 6 e raised to minus 6t is equal to 0. This should become 0. And therefore, what will be our answer?
Ma'am,
Yeah.
0.23 second.
Again, in the experiment, they don't give the answer in decimals, they give the answer in log form. So it will be 6 e raised to minus t is equal to 3 e raised to minus. Okay? And then we will get the answers, this will become 2. So e raised to minus 6t is equal to 1 by 2, e raised to minus 3t. Remove e raised to minus 6t by making it.
And we can take e raised to minus 3 to the left side.
Yes, absolutely. So 2 is equal to e raised to 3t minus 3t plus 6t. Right? We want
Yes,
to write
ma'am.
that.
Yes, ma'am.
So e raised to 3t and 2, and therefore ln of 2 into 1/3 is the time required in seconds. So ln 2 by 3 seconds is the time required for the charge to become maximum on the capacitor. Is it okay? Everyone? That's your final answer. Time required. Okay? We'll stop for the day today. I'll take your attendance. And again, students, let me stop recording and then.